Hello students, welcome to harichemistry. So this lecture we will learn solubility and solubility product. Okay, so the solubility and solubility product, every year we are is asking one question from this topic. So calculate the solubility product of the given salt, or if the solubility product will give, so calculate the solubility, and also pH based question and common ion effect based question are regularly asking in NEET and IIT-JEE mains level exam. So today we will learn the concept of solubility and solubility product. Okay, so students, so if you like my video, so please subscribe my channel. Thank you. So first we will start salts. Okay, so generally the salts are classified into three types. The salts are classified into three types. First one is the salts which are non-electrolyte. The salts which are non-electrolyte. So for example, means here it cannot be dissociated into ions when we are passing. The second type is soluble salts. The second one is soluble salt. So soluble salts means nothing but the salt which is completely dissociate into ion. So the salt which is completely dissociate into ion. For example, you can take a common salt, sodium chloride. So the sodium chloride is dissolved in water and it is completely dissociate. It is completely dissociate into Na plus and so chloride ion. So means in solution it dissociate into Na plus and Cl minus ion. So these type of salts we can call it as soluble salts. And the third one is sparingly soluble salts. Sparingly soluble salts. So sparingly soluble salts means nothing but the amount of salt which is not completely dissociate. The salt or substance which is not completely dissociate into ions. So means it forms an equilibrium between undissociated salt and dissociated ions. For example, we will take AB is a salt which is present in the solid form and it form an equilibrium between A plus and B minus. So it is not completely dissociated. Very small amount of salt is dissolved in water and the remaining amount of salt will be present in solution as a undissociated form. So then we can say it is a sparingly soluble salt. So this is very important in solubility and solubility product. Okay, the amount of salt or substance that will dissolve in given amount of solvent. Given amount of solvent is called solubility. So generally the solubility we can express with the letter S. So S is equal to the units are moles per liter. That is equal to mole per liter. So moles per liter. So the amount of salt is dissolved in solvent. So that is we can express in terms of moles per liter. Generally, the solubility it affects the many factors. So the first factor, these factors are very important. That is, the first factor is temperature. Temperature factors. So generally the solubility generally the solubility increases with temperature. Increases with temperature. So means the temperature increases, the solubility of a salt increases, or if the temperature will decreases, the solubility of a salt is also decreases. So this is the effect of solubility of on temperature. The second one is common ion effect. This is very important. Common ion effect. Common ion effect. So this is very important. Common ion effect. So generally, if any common ion will present in solution, it reduces the solubility of a salt. If any common ion will present, it reduces the solubility of a solid. For example, we'll take AgCl. So it is a sparingly soluble salt. So it is an equilibrium with Ag plus in aqueous plus Cl minus in aqueous. Generally, we are adding the small amount of for example, the 0.1 mole of silver nitrate is adding to this silver chloride solution. So generally it is dissociate in the form of Ag plus and NO3 minus. So here, if we are adding AgNO3 to the AgCl solution, so the Ag plus ions increases. So therefore the common ion is present. The common ion is Ag plus ion. So if the common ion is present, it reduces the solubility of AgCl. It reduces the solubility of AgCl and the equation shifts towards AgCl side. So means the reaction shifts towards the left hand side. So it shifts toward the reactant side. So that is very important when common ion will present. If the common ion will present in the solution, it reduces the solubility of a salt and the reaction shifts towards the reactant side or left hand side. That is very important. Next, the third factor is pH. The third factor is pH. So affects pH affects the solubility of pH affects the solubility of ionic compounds. pH affects the solubility of ionic compounds. pH affects the solubility of ionic compounds. Next, the fourth is the formation of complex ions. The formation of complex ions. The formation of complex ions. The formation of complex ions increases solubility. The formation of complex ions increases solubility of a salt. So means if the solution is going to be complex formation, so if the complex formation is going, so it increase the solubility of a salt. So these are the very important four factor for solubility. Okay, so the first factor. So we will take an example of a sparingly soluble salt. For example, the common salt is AgCl. So silver chloride we are taking. So this is AgCl. So it is sparingly soluble. So it's lot of salts are there. Sparingly soluble salt. It forms an equilibrium between Ag plus aqueous plus Cl minus aqueous. When these sparingly soluble salts are present in the solvent, for example, we will take a solvent, add sodium chloride, add silver chloride. So the small amount of Ag plus Cl minus will be present in the solution. Only very small amount of Ag plus and Cl minus ions will be present in the solution. The remaining amount of AgCl will be present as a solid. So only the small amount of AgCl is dissolves and the remaining amount will be present as a undissociated form. So here it is AgCl is not completely dissociate, it is in the form of undissociated species, undissociated salt, and it is dissociated, dissociated. So this is undissociated and this is dissociated. So these undissociated salt and dissociated ions are present in equilibrium. So we can explain based on ionic equilibrium concept. We can explain based on ionic equilibrium concept. Okay, so here generally S moles, so the AgCl is S moles per liter. AgCl, S moles per liter of AgCl is present in the solution. It present in the form of S moles per liter of Ag plus ions and the same S moles per liter of Cl minus ions. So if S moles per liter of AgCl will be dissolved in the solution, it dissociate into small amount of Ag plus and Cl minus ions. So this Ag plus is S moles per liter and Cl minus is also S moles per liter. So we will apply the equilibrium constant, that is K is equal to equilibrium constant K is equal to Ag plus in aqueous into Cl minus aqueous divided by AgCl salt. So generally commonly, so we considered of the solid as 1. So therefore here K is equal to Ag plus and Cl minus. So these K, so we called as a solubility product. We can called as K, we can called as solubility product. So that is we can represented as KSP. So that is the solubility product. This is